Okay, solving number 1, what we need to do is distribute this minus 2 to all the things inside the parentheses. So let's go ahead and do that first. I have 2 to the minus 2 times e to the minus 2 over e squared to the minus 2. Now if I ever have an exponent on top of a power, what we can do is just multiply those exponents. So I have 2 to the negative 2 times e to the negative 2. And on the bottom, if I multiply these two exponents, 2 times minus 2 is minus 4. Now, as if you recall, all the negative exponents, they just move. So this negative exponent on the bottom moves to the top, and both of these move to the bottom. So on top, I'm left with e to the 4th over 2 to the positive 2 and e to the positive 2. And now what we need to do is simplify. So first, 2 squared, well that's just 4. And then I can simplify the e to the 4th over e squared by just either subtracting their exponents or just thinking of them canceling out. I have 4 on top, 2 on the bottom. 2 of them are going to cancel, and I'm left with 2 left over on top. And that's my final answer, which is D. Okay. So looking now at number 2. So the way we're going to solve this problem is just by using SADMAP. Right? So that's always one of the best ways to find a solution whenever we see a problem that looks like this. So let me just rewrite this out. And my first step is to get rid of addition and subtraction. So let's go ahead and add this 3. Second, we want to cancel out multiplication division. So we have to divide this. Remember, you cannot distribute this when there's a squared here. So, because exponents, you can't multiply before you apply the exponent. So we can only undo this by dividing by 3. (48) divided by 3 is 16. And now we can cancel out our exponents. And if you remember, the inverse of having an exponent on there is to take the root, and it's the square root. And so this will cancel out with the power of 2, and I'm left with x minus 2 is equal to square root of 16 is 4. But since it's an even root, we have to put the plus or minus. So now when we split this up, we have 2 solutions to solve. X minus 2 is equal to positive 4. And x minus 2 is equal to negative 4. So solving this, I'm going to get x is equal to 4 plus 2 is 6, and here negative 4 plus 2 is negative 2. So I'm looking for the one that has 2, negative 2, and 6, which is C. For problem 3, if you remember, the best and easiest way to do this one is probably to just do it by factoring. So if we can factor out the height and the length, then whatever's left over is going to be the width. So let's look at this again. 16x to the 4th minus 56x to the 3rd plus 20x squared minus 70x. So the first step that's the easiest is to factor out a 2x first. So I can pull out that 2x in front and undistribute it or divide them all by 2x. So this divided by 2x is going to be 8x to the 3rd. 56 divided by 2x is going to be 23. Oops, that's not right. 28 x squared. 20 divided by 2x is going to be 10x. And then 70x divided by 2x is going to be minus 35. So there we go. We undistributed it. You can double check it just to make sure, but if we distribute back in, we should get the original problem. So that's one factor taken out. Now what we have to do is what's left over is take out the 2x minus 7. So the way we factor 4 terms is by grouping. So let's take a look at this. We're going to group the first two, and the second 2 and do the same thing, except this time we want to leave behind a 2x minus 7. So let's take a look at how that works out. So in the first one, if I want to leave behind a 2x, we have to divide by, looks like, 4x squared. So I'll pull out that 4x squared. And left inside, if I divide this by 4x squared, is 2x. And 28 divided by 4 is 7, so minus 7, and then the x squared is divided out. If I do the same thing with the other one, I want to leave behind a 2x again in the front, so I can divide it by 5 probably. And left behind is 2x and minus 7. If we did this correctly, the two things that we left behind for both of them was the 2x minus 7 that we were hoping for. And in front we still have the 2x. Then, if you remember, the last step for this is, well, whatever's left behind is one term, or one factor, and whatever we pulled out was the other factor, because we can just factor out this 2x minus 7. So last, we'll take the stuff that's inside. So those are the two we didn't want. So what was left over is the 4x squared and the plus 5. So here we have the height, the length, and then that means this must be the width, 4x squared plus 5. And last, for number 4 on this section, what we're going to do is to find the inverse. Well, that's just switching the x's and y's. So it's probably easiest if we can just put the y in first. That way we can think about switching the x and y's. And so all the inputs become outputs, all the outputs become inputs, so we just make all the y's, write them as x's, all the x's, write them as y's. And let's now solve for the y, since we want that as output, so we'll just get it by itself. So subtract 6. And then if I divide by 4, make sure you distribute it to both. I'm going to be left with x over 4, and then this second fraction reduces to minus 3 over 2. It's equal to y. And if you want, you can put in the correct order again and just throw in the function inverse notation. F inverse of x is equal to what we had, x over 4 minus 3 over 2. And that answer was D.